So, today we're solving equations. We have not done equations at all this chapter, other than, well, we graphed some, but we haven't done anything with solving yet. So the rules that we do today are different than the rules we have been doing. The rules that we do today are different than the rules that we have been doing. So here's our first example. We've got 3 over x plus 1 equals 9 over 4x plus 5. The first thing that we're going to do is we're going to look at this and we're going to say, we're trying to solve for x. Is there anything that x cannot equal? So the first thing I'm going to do is there anything that x cannot equal? Well, x plus 1 cannot equal 0, so x cannot equal negative 1. And 4x plus 5 cannot equal 0, so x cannot equal negative 5. That's step 1. What can x not equal? Now we're going to actually solve for x. And the reason why we said what x cannot equal is because when we give our answer, if I get an answer like x equals negative 1, then you know that that answer doesn't work. It's not allowed to equal negative 1. What would happen if I plugged in negative 1 here, if I went back to the beginning and I plugged in negative 1? You'd have 3 over 0 and the world would explode. You can't divide by 0 or the world would explode. Kidding. Okay. Okay, the next thing we're going to do is we're going to find the LCD, which is like finding our lowest common multiple of the denominators, which we've already learned how to do. So we're going to find our LCD, which is the lowest common multiple of the denominators. The lowest common denominator is the lowest common multiple of the denominators. So my 2 denominators, one of them is x plus 1, and the other one is 4x plus 5. To find the lowest common multiple, you factor that. So how do I factor x plus 1? Well, you can only factor one. I mean, you could take the 1 out, but you're right. It's really like its own factor. How do I factor 4x plus 5? For binomials, you first say, is there a GCF? No. Is it like squared so you can do difference of squared? No. Okay. So basically, this is also factored. They're their own factors. So when I talk about the lowest common denominator, or the LCM, remember what they have in common, you write, which they have nothing in common. And then you write everything else they don't have in common to put together. So we've got x plus 1 multiplied by 4x plus 5. That's my LCM, or my lowest common denominator, my LCM. Same thing. Okay? Now, what we have is we have an equation. If I do one thing to one side of the equation, as long as I do the same thing to the other side, I can do whatever I want. So I'm going to manipulate this equation until it doesn't have fractions anymore. That's my goal. So I'm going to do something to both sides of the equation that gets rid of the fraction. So what you're going to do multiply both sides of the equation by the LCD, lowest common denominator, or LCM, over what? By both sides by that LCD or the LCM that we just found over 1. And I'll show you why we're doing that. You're going to make sense once you see it. Go with me on this. The way I'm going to write it, though, I'm going to stay organized. And I'm using different colors so you can see the original question and what I'm multiplying by. I'm going to stay organized. So I have 3 over x plus 1. Then I'm going to multiply that by the LCD or the LCM. So I'm going to have multiplied by x plus 1 times 4x plus 5 over 1. equal sign 9 over 4x plus 5 multiplied by x plus 1 times 4x plus 5 over 1. So I just multiplied both sides of the equation by the exact same thing, keeps my equation equal. How do I multiply fractions? Straight across. So I'll just extend that line. And when I multiply on the left side, something's going to cancel. It's the sign. When I multiply on the right side, something's going to cancel. Or x plus 5. So now what do we have left over? 3 multiplied by 4x plus 5 equals 9 multiplied by x plus 1. No fractions. So now we just have an equation to solve. Hey, no more fractions. So let me write that step down, what we just did. So what number is that? Step 4?
Yeah.
Step 4. Multiply and the denominators should cancel. If you've done it correctly, that's what's going to happen. The denominators will cancel out. They'll cancel out with whatever's in the numerator. And then solve remaining equation. So now I'm just going to ask you, like, how do you solve this equation from algebra 1? Distribute, right? We get rid of our parentheses by distributing. So I have 12x plus 15 equals 9x plus 9. And then we will take away 9x from both sides. Take away 15 from both sides. 3x equals negative 6. X is negative 2. Now you just need to check this answer with those domain restrictions. Remember we had what x cannot equal? We have what x cannot equal right at the beginning, where x cannot equal negative 1 and x cannot equal, is it negative 4/5 or negative 5/4 or something? Negative 5/4. Can x equal 2? Negative 2? All right, well then we're good. If the answer was no, then you'd have to throw that out. And then we probably have no solution for that. Okay? Let's do another one. I'm not gonna do every single example in this packet. I'm just gonna go and do a few of them. So I'm going to skip ahead to number 3. That's on the front page. Okay. So the first thing that we need to do is we need to find the lowest common multiple, or the least common denominator of the two denominators. So just two, oh, actually, that's not the first thing. First thing I need to do is domain restrictions. Sorry. Domain restrictions. So if this cannot equal 0, then 2x cannot equal negative 5. That means x cannot equal negative 5/2. And over here, x cannot equal, we set that not equal to 0, x cannot equal negative 8/11. So those are my domain restrictions. Now we find our lowest common denominator. 2x plus 5, does that factor? No. 11x plus 8, does that factor? So since it doesn't factor, they're going to have nothing in common. So for our lowest common denominator, you just multiply them together. The things they don't have in common, you multiply together, that's our LCD. You multiply both sides of the equation by the LCD over 1. So I'm going to color code it. I'm going to organize my work, take some more space, but then I make a lot less mistakes. Multiplying both sides of the equation by that LCD over 1. I got my equation in black, I put my LCD in blue so you can see where I'm multiplying. That should, when we multiply straight across, that should give us things that cancel. And it should be the denominators that cancel, if you've done it correctly. I'm going to write what's left over after I cancel. So after we cancel out, what do I need to do? I need to distribute, get rid of those parentheses. We don't have fractions anymore, so that's good. Okay. Now, I have an equation that has an x squared in it. So I have to go back to chapter 2 and 3 from our year and say, how do I solve when there's an x squared in it? Jessica, how do I do it? I got to solve from here. How do I solve an equation that has like an x squared in it? Well, not yet, but I'm going to. What do I need to do first? I thought you had done it on your paper last night. I told you.
I don't know. Subtract the 5x squared.
Oh, did you make yours 2 negative?
Yeah.
Oh, see, I'm gonna put it on the other side because but you moved it over again.
Yeah.
Okay. We'll just go straight over to that side. So what you're gonna do is eventually, what did you make the equation equal? 0. That's what I was looking for. We need to say this equation equals 0 so that we can factor it, or maybe use quadratic formula. So I just think ahead and I'm going to say I want my x squared term to be positive. So I'm going to move the 11x and the 8 over. So I'm going to subtract that. So now I have 0 equals 2x squared minus 6x minus 8. And that's a trinomial, and we can factor it to try to solve for x. What's our first step of factoring? GCF. If there is one. And from there we do guess and check. I'm doing it fast, but we've been doing this for a long time. Once you have it factored, x 2 times x minus 4 times x plus 1. Once you have it factored, then you set each factor equal to 0. Do I solve 2 equal to 0? No, because 2 doesn't have a variable. We only want to know what x equals. So we do x minus 4 equals 0. Hey. And I get x equals 4. And we solve x plus 1 equals 0. We get x equals negative 1. So we got 2 answers. So our last step is let's go back and look at those domain restrictions. Did we have any restrictions that said that x cannot equal one of these numbers here? No, our x restrictions were weird fraction things. So we're good. We have 2 answers, so I'll just put it in order with fancy brackets. Set notation. There you go. So we're ready to go on. Turn the page so I know you're ready. And get next. We're actually going to go to example 3. You're going to start out example 3 the same way that you just started out the first example that we're doing. So what's our first step? Domain restrictions. Do it. Yeah. Well, we'll do A and B. So yeah. So we look at my domain restrictions. We look at the denominators. What can x not equal? 0. It's the only thing that x cannot equal. If x is 0, then we are dividing by 0, and the world blows up. Okay. Now we're going to find our lowest common denominator. So we're going to look at our denominators. We have an x, and then we also have a 4. And then we also have another x, but that's the same as the other x, so I don't really need to think about all 3 of them. These are totally common already. So I don't really need that. Just think about what's common about x and 4. Anything? So if nothing's common, how do we find the common denominator? When we did our LCM and we circled what's in common, I'm not circling anything. What did we do with the stuff that wasn't in common? Like, moved it down. So what's our LCD? 4x. So I'm going to multiply each fraction by 4x over 1. I'm going to multiply both sides of the equation by 4x over 1. So I put a 4x over 1 by each part of the equation, both sides. Remember, when you're multiplying, you're just like, multiply those fractions straight across. Does anything cancel in this? Oh, I forgot. Does anything cancel in this first section? On top and bottom. The x's cancel, right? So I have left over 20. Plus, when I multiply the second term, what cancels? The 4's. And we have left over 7x. And then on the other side of the equal sign, I multiply these together. The x's cancel. I get negative 36. So the reason why we multiply by the denominator over 1 is because it will cancel every denominator in one step. So if your denominators don't cancel, or if you say to me, nope, nothing cancels, then you've done something wrong. That was the whole point of multiplying by that number, to cancel. So now we just have an equation that you look at and you go, oh, this is an easy one to solve. Take away 20. 7x equals negative 56. Divide by 7. X is negative 8. Check it with our domain restrictions. Can x be negative 8? No, allowed? Yes, just can't be 0, so we're good. X is negative 8. And we're going to do b as well. We're going to do b. So what's the first step? Okay, I got my domain restrictions, 5 and 0. Then I have to do the LCD, or the lowest common multiple, but I have to do it for every single fraction, which means every term has to be a fraction. You see that very first term is not a fraction quite yet? The first term is 1. How do I make 1 into a fraction? Oh, okay. But I tried. There we go. Now it's a fraction. Now we're going to go. So when we do our lowest common denominator, we've got a 1, we've got an x minus 5, and we've got an x. None of these are factorable. So they have nothing in common other than a 1. What do I bring down to find the lowest common denominator? What do I bring down? Everything. So we'll have 1 times x minus 5. Put it over 1. That's what we're multiplying everything by. So I'm gonna write all the black marker first. I'm gonna go put in the LCDs because I don't want to keep switching markers. Just if you're looking at my work, that's what I'm doing. But I'll have it complete in just a second. Multiply every part by LCD over 1. When you multiply, something should be canceling. So look here. What cancels? 1? Okay. Not really anything, but x times x minus 5 is left over. We have minus 8 x. The x minus 5 is canceled. Equals over here, we multiply these, and the x's cancel. 3 times x minus 5. And then we have no more fractions. Yay! And it's just like algebra 1 solving. How do I solve this? What do I do first? Get rid of the parentheses. You got to distribute. And then we're going to combine like terms. So I'll have x squared minus 13x equals 3x minus 15. Since I have an x squared in it, I'm going to probably be factoring. So I need to say equals 0. We'll move that stuff over. We'll have x squared minus 16x plus 15 equals 0. And if it's not factorable, then you have to use quadratic formula. Factor my guess and check. Don't stress over this one. It's just minus 1 and minus 15. Once you solve it, then you go back up to the beginning, or domain restrictions. 1 and 15, either of those have a problem. They're both good. So then we have 2 answers. We write x equals 1 and 15. Let me turn the page. And we go find example 4. So actually turn it over. Example 4. So you've seen this word a couple times in here. Do you remember what it means to have an extraneous solution? Remember what I mean? It means like extra. It means when you check it, it doesn't work. So these are going to have extraneous. But you'll know it's extraneous because what's going to happen is when we find our domain restrictions at the end, one of our answers is going to be that domain restriction. So you just throw it out. So let's do this. Domain restrictions. X cannot equal 3. X cannot equal negative 3. How do I find the domain restriction for the middle? I can factor it, yeah. So that is x plus 3, x minus 3. So the domain restrictions are just positive 3 and negative 3, what the other stuff is. So we're good on our domain restrictions. If we get an answer that's positive 3, or if we get an answer that's negative 3, we have to throw them out. They're extra. They do not make this equation true. Next, lowest common denominator. So we've got our first denominator, x minus 3. Our second denominator is x plus 3, x minus 3. And then our third denominator is x plus 3. So you're kind of doing the lowest common multiple thing, but we have 3 of them, and we didn't really do this with 3 of them before. So some of them have some of them in common, some of them have nothing in common. I'm going to look at the ones that have nothing in common. Okay? So I'm going to look at this one and this one. What would you have to give each other to make them the same? What would you need to give that one? I did not understand what you said. I'm sorry. -1? No. Because that would make, if this was our denominators, or our lowest common multiple, like, remember how you circle what's in common? I'm ignoring the guy in the middle. We circle what's in common, so over here we got nothing in common. And then we bring down what's not in common. So what would I need? I would need, over here I need the x plus 3. And like over here I need the x minus 3. We'd have to bring them both down, multiply them together. Now I'm going to do the LCD with these two. See how they're already the same. So I don't need to give anybody any extra, like they're exactly the same. So our LCD that we're multiplying by is x plus 3 times x minus 3. Lowest common denominator. Now I'm going to write one color at a time, so I'm going to do all the black pens, then I'm going to do all the blue pens second. So we're going to multiply by this over 1. So I'm going to have 6 over x minus 3, and I'm going to have a space. 8x squared over x plus 3, x minus 3, no space, and that's 4x over x plus 3. Multiply each of those by x plus 3, x minus 3 over 1. Remember, when you multiply, you go straight across so we can cancel stuff. From the first fraction, the x minus 3's cancel. So I have 6, parentheses, x plus 3 left over. And then equal sign. From the next one, we have both x plus 3 and x minus 3's cancel. So 8x squared. And on the last one, the x plus 3's cancel. So I have minus 4x multiplied by x minus 3. We should have no more denominators, no more fractions. Now we're doing like algebra 1. Let's distribute to get rid of our parentheses. 6x plus 18 equals 8x squared. Minus 4x squared plus 12x, because we distributed a negative, that turned it into a positive 12x. Start combining like terms. Also, since there's an x squared in it, I'm going to have to make one side equal 0. So when I combine 8x squared minus 4x squared and I get 4x squared, I'm going to move everything to that side of the equation so it stays as a positive 4x squared. So I'm going to subtract 6x and subtract 18. And we will factor it. First step of factoring. GCF, there is one. 2. Then, since it's a trinomial, we'll guess and check. I know it has to be a 2x and an x. With 9, it could be a 9 and 1, or it could be a 3 and 3. I'm going to guess 3 and 3. And then when I check it back, multiply these, I'll get a 6x, I'll get a 3x. Is that somehow going to give, oh, that's wrong. I messed up. You all didn't stop me. I messed up. When I subtracted 6x here, I didn't write 6x. That should be pretty. There we go. Did you see what I messed up on? Sorry about that. 6x should be here and then 3x. So then I'm foiling this back together, and I have a 6x and a 3x. Is that anyway going to give me a 3x? 6 and 3, can that make 3? If we subtract them. So that means this has to be the minus. So my minus sign goes here, my plus sign goes there. So we have it factored. We set each factor equal to 0. So we have 2x minus 3 equals 0, and we have x plus 3 equals 0. So x equals positive 3 halves, or x equals negative 3. What's our last step? Check the domain restrictions. Do either of them say one of my answers here? Yeah, we have the domain restriction of x cannot equal negative 3, so say, reject it. You are not an answer. We only have the answer of 3 halves. Now, if you reject both of them, then it would be no solution. So that could happen. Hint, hint, that might happen in homework. And the answer would be no solution. All right, we're almost there. We got one more thing to do. Last thing. Example 5. Example 5 is complete review. With the exception of it's a different equation, but it is review. Example 5 is determine if the function is an inverse and also find the inverse. So let's go over how to find the inverse. Go over finding the inverse. And then the function will not be an inverse. It won't be an inverse. If the exponent on like the x is even, then our function will not be an inverse. I mean, now our inverse will not be a function. So determine if it is a function, if the inverse is a function. You look at your x, is that even or odd on the x exponent? Odd, so if yes, it will be a function. If it was a square, then you say nope, not a function. Then we have to find it. So how do we find it? No, I do not know why it does that. What is our first step? Change the f of x into y. What do inverse functions have? Like, how do you know they're inverses? What do they do? Switch the x and y. So what's my next step? Switch x and y. So now I have x equals 2 over y plus 3. Now I'm going to make these both into a fraction. You ready for this? I'm going to go both into a fraction. Ready? All right, now I'm going to fraction. Now we can solve this a number of ways, but since I have I want to think ahead of time before I. Since right now I have a fraction equals a fraction. I have a fraction equals a fraction. There's this really cool thing that you can do in math. Got the bridge in between the two fractions. You can actually do this thing called cross multiply. So I do 1 times 2 and I get 2 equal sign. You bring the equal sign down. And then I'm going to multiply x times y plus 3. But remember y plus 3 is in the understood parentheses that you don't see. So I'll have x multiplied by y plus 3. But I'm not going to multiply it out. Don't multiply it out. Waste of time. So you could have also done this the way we were doing the other homework where you find the LCD and you multiply both sides by LCD over 1. So I'm just showing you a different way of doing it at this moment. You could also, at this step, multiply both sides by LCD over 1, and you will get the exact same thing that I have here if you do that. Now, my goal is to get y by itself. What is the furthest thing, if you think about y having layers around it, what's the furthest layer I need to get rid of? X. So x is being multiplied. How do I get rid of it? Divide. So we'll divide both sides by x. And I will have 2 over x equals y plus 3. So now what do I do to get y by itself? Subtract the 3. So I have 2 over x, subtract 3. And since it is a function, I can go ahead and rewrite it as g of x instead of y. But y and g of x would be the same thing. Let me find one more to go over, just like that. So this one right here, slightly different, right? Let me make sure. Is that one different? Yeah. Okay. So the first thing we're going to do is determine if the inverse is a function. Do we have an even exponent? So we're good. It is a function, so this is a yes. So we'll write y equals 1 over x minus 2. Then what do I do? Switch x and y. So I have x equals 1 over y minus 2. So y has layers. What's the outer layer that I need to get rid of? What do I need to get rid of? The minus 2 how? Add 2. So we have x plus 2 equals 1 over y. Now y is in the denominator. So we can do multiply both sides by the lowest common denominator, or we can do this cross multiplication thing if I have one fraction over here. Do I have a fraction over here? Can I make it look like a fraction? What can I do? Split it over 1. So if I cross multiply, now I have y parenthesis x plus 2 equals 1. Now my goal is to get y by itself. Y is being multiplied by x plus 2. How do I get rid of the x plus 2? The operation right now is multiplication. What's the inverse of that? Divide. Division. We divide both sides by x plus 2. So that cancels those. And we get y equals 1 over x plus 2, or since it's a function, we can write g of x equals 1 over x plus 2. You have to use the same rules you always use in math to solve these, but to get the y out of the denominator, we're going to be using cross multiplication. Okay, we have 8 minutes. You have a big idea online. So grab a computer and begin it. If you're not beginning it online, then you are beginning it on paper and putting it on the line later. Either way, you're not sitting here for 8 minutes staring at the screen. The assignment that we did not grade today, we grade it tomorrow, bring it tomorrow. Also, that massive packet, you did all the odds, bring that. I hope you have done that. Yeah, well, not 2. But 1 week. 1 week.